Hi Year 10s, we are starting our new topic and it is called probability, but the first exercise is all from Year 7, 8 and 9. So I will let you copy down the notes first, pause it when you need to, and then I'll talk in a minute. Cool. Alright, Year 10. So, probability, I'll go through all my notes. So there's a few definitions first. So a trial is a single experiment, such as rolling a dice. If we're saying we're going to roll a dice and we're going to see what number comes up, whether a 6 comes up, that is called a trial. Or tossing a coin. And a lot of the time you might have 20 trials all at once. You might do the same action 20 times. Sample space is a list of all the possible outcomes. So rolling a dice, the sample space is 1, 2, 3, 4, 5 and 6. They're all the possibilities you can get. Tossing a coin, you could get a heads or a tails. So what you need to do, that means sample space, and then in brackets of a coin. Now you put these curly brackets, they're called braces, heads and tails. Just literally list what the sample space is. So if I said what's the sample space of randomly picking a month of the year, you put those brackets and you write January, February, March, April, all the way to December. Okay. An outcome is a possible result of an experiment. An event is a collection of favourable outcomes. That's like getting a 3 on a dice. That's a favourable outcome if that's what you're after, a 3. And then it says here, equally likely outcomes have the same chance of occurring. So you'll hear things like a fair dice. That means it's not biased. It's not a trick dice or anything. A fair dice has a 1/6 chance of any number coming up out of the 6. And it said they're not a biased dice. A biased dice is a weighted dice. So when you roll it, it might favour one of the numbers. So an equally likely outcome just means it's a fair, whatever the object is, a dice or a coin. Alright, next thing, the probability scale from Year 7 and 8. So you notice it goes from 0. A probability is from between 0, which means it's impossible. It cannot occur, has 0 chance of occurring, all the way up to 1. 1 means it is certain, it must occur. So there's no chance that it cannot occur. It must occur. Right in the middle is 0.5, and we call that even chance. There is unlikely and there is likely. So these words just describe somewhere in that region. You can say very likely if it's closer, or very unlikely as well. So you can use words to describe the probability of something occurring, or you can use decimals, or you can use percentages or fractions. So you could say a half, 1 out of 2, or 3/4 would be there, or you can use 50% or 80%. So all of those are the same. So any of them work? Good job. Next one. Now you need to know the difference between theoretical probability and experimental probability. So theoretical is just using the maths. So the probability of any event occurring, the formula is the number of favourable outcomes over the total number of outcomes. So for instance, rolling a dice, a 6-sided dice, you've got one favourable outcome, because that might be, your favourable outcome might be how many 6s do we get? So getting a 6. So there's one chance of getting a 6 over the total number of outcomes. How many outcomes are there? Or another way is what's the sample space? 1, 2, 3, 4, 5, 6. There's 6 chances. So the probability of getting a 6 is 1 out of 6. Or the probability of getting a 2 on a dice is 1 out of 6. Because there's one chance out of 6. Now experimental probability, this is the probability of an event, is number of favourable outcomes the same over the total number of trials. So this time, they want you to know the difference between if we tossed a coin 10 times. In theoretical probability, you'd expect 5 of them, 5/10 to be heads and 5 of them to be tails. When we do experimental probability, if we said what's the probability of getting heads, and you've done it 10 times, you might get 7 out of 10. And that's because in an experiment, you do not always get the theoretical probability. So when you just do, obviously if you toss a coin, we expect, out of 2, you expect 1 head and 1 tails. But you could get 2 heads or 2 tails. So it's not always, the experimental probability is not the same as the theoretical probability. But I've said here, long run proportion. So what that means is, the more times we do a trial, the closer we get to the theoretical results. So if I tossed a coin 10 times, we might get 7 and 3 of one or the other. But if I did it 1,000 times, you're very likely to get much closer to the 500 heads and 500 tails. If we did it 1,000,000 times, you're going to get much more accurate results. So that's what that means. The more times you do something, the more accurate it becomes. Alright, so I made this question up myself. A letter is chosen from the word corona. So, find the probability of getting an A. This is pretty simple. There's one chance of getting an A out of 1, 2, 3, 4, 5, 6. Out of 6 letters. So it's 1/6. The probability of getting a vowel is A-E-I-O-U. So there's 1, 2, 3. So we get 3 out of 6, which can be simplified to a half. Always try to simplify your fractions. Now, the probability of getting a D. Where's the D? There's no D in that letter, so there's 0. 0 out of 6, or in other words, it's just 0. So that is impossible. There is no chance of that happening. And the probability of getting a C or an O. So there's a C or an O, so you count them all, and there's 3. 3 out of 6, which is equal to a half. Good job. That's an easy one. And let's go up here. Another question. 3 coins are tossed 100 times. So in our situation, we've got 3 coins. We toss them all together 100 times. And this table lists how many heads we get. Here we've got, how many times do we get no heads out of the 3? We've got 11 times out of the 100. We've got 1 head 40 times, 2 36, and 3 13 times. Alright, so this is experimental probability because we did it from our experiment. Alright, so the probability of getting 0 heads. There's 11 chances of that happening out of 100. So that's the probability from our experiment. Alright, the next one. What's the probability of getting 2 heads? 2 heads is there, 36 out of 100. And you can simplify that, you can do that yourself. Probability of less than 2 heads. Now you've got to be careful with the language here. Less than does not mean 2. It means less than 2 is 1 or 0. So 1 or 0, add those 2 together, it's 51. So it's 51 out of 100. So if it said not more than 2, that would be 0, 1 and 2. But you've just got to be careful of the wording. And here, probability of at least 1 head. So there's at least 1, there's 2, and there's 3. We add those together, 76, 86, 89. So I get 89 out of 100. Excellent. And that's that question done. And that's all for exercise 8A. We have a couple of, you've got questions there you can do. Take your time, it is revision, but make sure you do it properly. Now there's a tip here. With probability, we expect you to know certain things. For instance, what a vowel is and a consonant. So for words like that, they'll just say, how many vowels are there? You have to know what they are in a test. Another thing, you need to know prime numbers. Prime numbers are numbers that don't have any factors other than 1 in themselves. By the way, the first prime number is 2, not 1. First prime number is 2, and 3, 5, 7, 11, 13, 17, and so on. So make sure you refresh your memory on prime numbers. Factors. Factors are numbers that divide into another number. And you must be familiar with a deck of cards. So you have to know what suits are, the 4 different suits. So you've got diamonds, hearts, clubs and spades. The colours, black and red. And then all the different types of cards as well. So there's questions on that. We expect you to know that for all the tests. Awesome! I'll see you next time, and don't forget, smash that like button.